This video presentation is on step-up operation of single-phase to single-phase bridge-type cycloconverter. In step-up operation, the output frequency is greater than input frequency. So, FO will be greater than Fs. Remember this. In step-up operation, the frequency of output signal, output AC signal, is greater than frequency of input AC signal. In this type of cycloconverter, we have to employ forced commutation. Why it is required, we'll come to this later. Before moving further, let us recall what we learned in our last video. So this is the typical circuit of single phase to single phase bridge type cycloconverter. In this we have AC source Vs, the load, and two group of thyristors P1, P and N, the positive group and the negative group. And recall the working of this cycloconverter. If positive output is required and supply is also positive, then P1 and P2 are active. To obtain negative output when positive supply is available, N1 and N2 are active. When positive output is required when negative supply is available, then P3 and P4 are active. And last, for negative output in case of availability of negative supply, N3 and N4 are active. So with knowledge of this firing, we can have step-up operation from this circuit. To understand what is step-up operation and how we are going to proceed with firing of different thyristors, let us take an example where we have to obtain an output frequency which is twice the supply frequency. So these are the waveforms of input and output. Mind you, this will be a just representation of a type of output that is required from cycloconverter, step-up type of cycloconverter, but this is not the actual output of bridge type cycloconverter. So let us understand first how we have to proceed to switching schematic of step-up operation in a single phase to single phase bridge type cycloconverter. To understand that, let us take an example where we have to obtain output frequency which is twice the supply frequency. So this is one cycle of input or supply. So if the output frequency is twice the supply frequency, it means that there have to be two cycles of output for one cycle of input. So each cycle of input will have two cycles of output. In that case, each half cycle of input will have one cycle of output. Each half cycle have one cycle of output. Each half cycle has one complete cycle of output. So to obtain one complete cycle of output within this half cycle of input, we have to perform two switchings because the supply goes from 0 to positive, positive to negative. So there have to be two switchings. One switching will be of positive group P group so that output is positive, and the next switching will be of N group or negative group to obtain negative output. So in each half cycle there will be two switchings between different thyristor groups. That is, this switching will not be between P group and P group or N group or N group. This switching will be between P group and N group. So in complete cycle of the input, each cycle there will be two times this switching. So there will be four switchings in complete cycle of the input. So 1, 2, 3 and 4. There will be 4 switchings because output is positive, negative, positive, negative in this duration. So to obtain this output where there are 2 cycles of output, we have to have 4 switchings. And each switching will then occur at an interval of 90 degrees. This is a complete cycle of input expanded over 2 pi radian or 360 degrees. And to obtain 2 complete cycles of output, we have to perform 4 switchings. Therefore, each switching will occur after each 90 degrees, as we have seen in this example. Now let us try to generalize these things. So to obtain output which is n times the supply frequency, there will be n cycles of output for each cycle of input. There will be n by 2 cycles in each half cycle. So similarly, there will be n number of switchings in each half cycle, and that too between different thyristor groups. Similarly, in that analogy, in each cycle we have to perform 2 times n switchings. So if there are n switchings in each half cycles, there will be twice that number in complete cycle. And in that case, switching will occur after every 360 divided by 2n degrees. So let us recall all that we have learned about cycloconverter's step-up operation. So this is the circuit. There are 2 groups of thyristors, P and N. For step-up operation, output frequency must be greater than supply frequency, and to obtain positive output, P group are activated. For negative output, N group thyristors are activated. When positive supply is required, positive supply is available and positive output is required, P1 and P2 are fired. For negative output, N1 and N2 are fired. When negative supply is available, for positive output, P3 and P4 are fired, and for negative output, N3 and N4 are fired. So we have a very good knowledge that to obtain a particular output for availability of a particular supply, which set of thyristors must be fired. Then from the last example and an analogy from there, we understand that to obtain an output frequency which is n times the supply frequency, there has to be n switchings in each half cycle, and those switchings will occur after every 360 by 2n degrees. So with this knowledge, let us try to understand the actual operation of cycloconverter in step-up mode. Let us take up our first example where output frequency is exactly twice the supply frequency. So this is the circuit for single phase to single phase bridge type cycloconverter. This is the table that represents that for particular type of output at particular supply, which set of thyristor must be fired, and these are the information which tell us how the switching must be done in order to perform step-up operation. So this is the supply with RMS value Vs. A complete cycle of supply is within the range of 0 to 2 pi radians or 0 to 360 degrees radians. Since the output across the load will also be negative of the supply voltage sometimes, we draw the negative envelope as well, minus Vs supply. Now, as discussed in last example and also mentioned in this slide, to obtain twice the supply frequency and output, there will be 4 switchings in total, and each switching will occur at an interval of 90 degrees. Therefore, we have segregated 4 intervals for one cycle of input. So the first interval is from 0 to pi by 2 radians, 0 to pi by 2, that is 0 to 90 degrees. Then pi by 2 to pi radians, 90 to 180 degrees. Next interval is from 180 to 270 degrees. And last interval is from 270 degrees to 360 degrees. Now we have to obtain 2 cycles of output. So the output must go positive Vs first time, then it must go to negative, then it should bounce back to positive, and it should reach negative again to complete 2 cycles, right? So output will be positive, negative, positive, negative. Then only we can obtain 2 cycles of output for one cycle of input. Now we already know that in the first interval, that is from 0 to pi by 2 radian, supply is positive and output required is positive. So when the supply is positive, output is also positive, the thyristors P1 and P2 must be fired. Similarly, in second interval from 90 to 180 degrees, the supply is still positive, but output required is negative. Therefore, thyristors N1 and N2 must be fired. So, in similar manner, we can have the firing sequence like this. In first interval 0 to pi by 2 radian, P1 and P2 to obtain positive output. Then N1 and N2 in next 90 degrees to obtain negative output, that is from pi by 2 to pi radians. In third interval, that is from pi to 3 pi by 2 or 180 degrees to 270 degrees, we have to again obtain positive output. Therefore P3 and P4 are fired, and in the last interval N3 and N4 are fired. How? Let us take the case of first interval. So in first interval, as we have already decided that we must obtain positive output and the supply is positive, so according to this table, thyristors P1 and P2 must be fired. When P1 and P2 are fired, the current flows through the devices and load as marked by these arrows. Therefore output is positive. The output is now shown in this dark green line, which is equal to Vs. So in this interval 0 to 90 degrees, output voltage V0 is equal to plus Vs. So the output is like this. In next interval, the output must be negative. If output is negative and the supply is positive, N1 and N2 thyristors must be fired. So now N1 and N2 thyristors are active in the interval pi by 2 to pi radians. Now you can see that positive terminal of the supply is connected to negative terminal of the load through this thyristors N1. This means the output is negative, and it is drawn like this. So we have seen in one half cycle, this is one half cycle of the supply, there are one cycle of output. In each half cycle there will be one cycle of output. This is one cycle of output, positive and then negative. There are two switchings in each half cycle, two switchings. First P1 and P2 were fired, and then N1 and N2 were fired. And in that case each switching occurs after each interval of 90 degrees. So first interval was from 0 to pi by 2 radians or 90 degrees, and after that 90-degree interval N1 and N2 were fired. Now at pi radian we have to switch again. Now in this interval, to obtain another cycle of output, the output must go to positive value. So to obtain positive output, and we already know that in this duration after 180 degrees the supply Vs has reversed. So in this duration supply is negative but output has to be obtained positive, so we fire P3 and P4. As soon as P3 and P4 are fired, the current flows in the direction marked by these arrows. So we can see the output is positive in this case. So the output is shown like this. And in the last interval, we have to perform another switching. And in this case, to complete another cycle of output, we have to obtain negative output. Since output is to be obtained, a negative output is to be obtained, and supply is also negative, we fire thyristors N3 and N4. In that case, recall from the last video, output will be negative. So in this way, two cycles of output are obtained. This is cycle number 1 and this is cycle number 2. So mind you, there are two cycles of output for one cycle of input. Therefore, the output frequency is twice the supply frequency. So the summary for step-up operation of cycloconverter, when we have to obtain 2 times the supply frequency, there will be 2 switchings in each half cycle, a total number of 4 switchings, and each switching will occur after an interval of 90 degrees. So a complete cycle of input is divided into 4 intervals, each of 90 degree, and then alternatively thyristor groups are fired: P1, P2, N1, N2, P3, P4 and N3, N4. Mind you, if we have to consider only one half cycle and we have to obtain a higher number of frequency, then there will be number of switchings that will be repeated, and we'll see that in next examples. So this is the summary of output of step up cycloconverter, where output frequency is twice the supply frequency. There will be 4 switchings, each at 90-degree intervals. Now let us take an example of another operation of step-up cycloconverter, where output frequency is 3 times the supply frequency. Since the output frequency is 3 times the supply frequency, there will be 3 switchings in each half cycle of input and 6 switchings in total. Therefore, the 360-degree interval of the supply of the input must be divided into 6 sub-intervals, and there will be 6 switchings each at an interval of 60 degrees. So we have divided one cycle of the input into 6 sub-intervals, each of 60-degree duration. First is from 0 to 60 degrees, then 60 to 120 degrees, 120 to 180 degrees, 180 to 240 degrees, 240 to 300 degrees, and 300 to 360 degrees. We have to obtain 3 times the supply, 3 times the supply, 3 times the input. So there will be 3 cycles. Since there are 3 cycles, there will be 6 switchings. So switchings will be like this. First way, output must be positive, then negative, positive, negative, again positive and negative, so as to obtain 1, 2 and 3 cycles of output for one cycle of input. And according to the same working as we have seen in the last example, the devices will be fired in this particular manner. So the output will look like this, and the firing sequence is like this. Let us take the first half cycle only. In this first half cycle, the supply will be positive. From 0 to 180 degrees, the supply will be positive. And in this duration, we have to obtain 1.5 cycles of output. So there are 2 positive cycles of output, or 2 positive parts of output and 1 negative part. So whenever we have to obtain positive output for positive supply, P1 and P2 are fired. So the sequence is P1, P2, N1, N2, because negative output is required, and then P1 and P2 again. So the sequence is P1 and P2, N1 and N2, and then P1 and P2 again, because output required is positive, negative and positive, and in this duration the supply is positive. As the supply reverses after 180 degrees, we have to move back to 3 and 4. Remember this, whenever supply is positive, to obtain output, the thyristor marked numbered 1 and 2 are fired for positive P groups, for negative output N group. Whenever negative supply is there, we have to fire thyristors with number 3 and 4. For positive output P3, P4, for negative output N3 and 4. So in negative half cycle of the supply, we again have to obtain 1.5 cycles of output. Since in the duration 120 degree to 180 degree, positive output was obtained, to complete one cycle of the output after 180 degrees to 240 degrees, the output must be negative. So we fire the thyristor group N3 and N4 first. Then we have to obtain positive output. For negative supply, we fire P3 and P4, and in the last interval, to obtain negative output for negative supply, we fire N3 and N4. So to summarize, for 3 times output frequency, there are 6 switchings, each at an interval of 60 degrees, and the firing sequence will be like this. For positive half cycle, group marked, thyristors marked 1 and 2 are fired. For negative half cycle, thyristors marked 3 and 4 are fired. For positive, P groups are fired. For negative output, N groups are fired. So 3 times the output, 3 times the input supply frequency, 6 switchings, each at 60 degree interval. Firing sequences P1, P2, N1, N2, P1, P2, N3, N4, P3, P4 and N3, N4. So this is the output. Similarly, for obtaining 4 times the supply frequency, that is the output is 4 times the input, we will have total number of switchings as 8. For 4 times the input, there will be 4 switching in each half cycle, 1, 2, 3, 4, and 8 switchings in total, and each at an interval of 360 degrees divided by 8, that is 45 degrees. So we have divided one cycle of input. This is one cycle of input. For 4 times the input frequency, to obtain output as 4 times the input frequency, there are 4 switchings in half cycle, 8 switchings in each complete cycle in 8 intervals, and each switching will occur at 360 degree divided by 8, that is 45 degrees. So firing sequence is like this. There will be 2 cycles in each half cycle. Therefore P1 P2 N1 N2 P1 P2 and N1 N2. In negative half cycle, P3 P4 N3 N4 P3 P4 N3 N4. So there are 1, 2, 3 and 4 cycles of output for one cycle of input. So that is step-up operation of cycloconverter. And last example is for where we have to obtain output frequency which is 6 times the supply frequency. Since output is 6 times supply frequency or the input frequency, there will be 6 switchings in each half cycle. This is one half cycle, positive half cycle. There are 1, 2, 3, 4, 5 and 6 switchings. In total, for one complete cycle of supply, there will be 6 into 2, 12 switchings. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 switchings. And each switching will occur at an interval of 360 degrees divided by 12, that is 30 degrees. So to obtain 6 times the input frequency, 12 switchings divided at an interval of 30 degrees, and the output is like this. So there are 1, 2, 3, 4, 5 and 6 cycles of the output. In next video, we'll discuss the step down operation of cycloconverter. Thank you.